It is now time to introduce you to our Public Affairs Officer, Brandy Dean, and our special guest, Dan Gazda, who is a chemist here at the Johnson Space Center. So, Mission Control, I introduce you to St. Peter's Preparatory High School.
Hi, thanks so much, and welcome to the Mission Control here in Houston. We're in the International Space Station Flight Control Room. And like you said, I have with me Dan Gazda, who is an environmental scientist and chemist. So hopefully, I know y'all sent in a few questions ahead of time. A lot are studying chemistry, and hopefully he'll be able to help you with that. But first, I'm going to let him tell you a little bit about who he is and what he does.
Yes, as you mentioned, my name is Dan Gazda. I work in the Human Health and Performance Directorate here at JSC. I'm an environmental scientist in the Water and Food Analytical Lab, and our primary responsibilities are supporting the environmental health systems and the environmental control and life support systems on ISS.
All right. Well, thanks so much for joining us, Dan. We really appreciate it. And I guess if y'all want to start with your questions now, that would be perfect.
JC.
That's it. Oh, the lady that spoke to us prior to you guys, she said that on space some metals are made that wouldn't be able to be made on Earth. What happens if you bring those metals that can only be made in space to Earth? Like, would they, come apart or something like that? Or what would happen, or would nothing happen at all?
Generally speaking, when you're in the microgravity environment, you're able to do things that you can't do in a terrestrial laboratory here on Earth. And so with metals, you can alloy metals and mix them in unique ratios to achieve desired properties. So you can mix these things in space and allow them to form with the specific ratios in the alloy. But once they're formed, they should be locked into place so they can be returned to the ground and studied.
I was just wondering, like, how close are we to, like, sustaining a community in space, like in the movie, like, Wall-E, like, where they had a big ship and they can go, like, wherever they want?
How close? Closer than we were several years ago. One of the exciting things, some of the exciting progress that we've made in the past couple of years is really moving towards a closed loop life support system on the space station where we're now recovering water from urine and scrubbing the atmosphere, recovering some water through a Sabatier process. And what this does, this dramatically reduces our reliance on ground supplied resources and does move us closer to having the ability to sustain a population of folks out in space on a long duration mission without having to constantly resupply things from the ground.
And I think I don't know necessarily about Wally, but although it's a great movie, we do get a lot of inspiration from science fiction and occasionally movies, right?
There are a lot of folks working at NASA who definitely watched a lot of science fiction.
Definitely.
And there are certain aspects of science fiction that are more realistic than others.
What materials were used in the astronaut suits to ensure their safety? Like, I'm guessing they have some pretty high-end insulation because I hear space is pretty cold. And like, also, what materials used to block radiation because that could be pretty dangerous for them out there?
Yes, I'm not familiar with the exact materials that go into the outer shell of the extravehicular mobility units, the EMUs. Those are the suits that the astronauts wear during spacewalks, or EVAs, the extravehicular activities. They are multi-layer materials, so what you have is a unique combination of many materials stacked on top of each other to provide the desired characteristics and ensure crew safety during spacewalks. They do have certain materials in the suit that reduce the radiation exposure, but when you're in space, the radiation exposure is going to be higher than it is on the ground.
And I think they also have, at least in their gloves, heaters that help them keep warm. You'd asked about insulation. It definitely does get very cold in space, and you especially want your hands to be warm because you work a lot with your hands. So to help them keep from getting stiff fingers, they have heaters inside their gloves.
Yeah, they actually have some very unique undergarments for the spacesuits called liquid cooling and ventilation garments that look a lot like thermal underwear, but they have very small diameter tubing that liquid circulates through and passes through a heat exchanger that helps regulate the temperature inside the suits.
Because you also get hot in space when the sun is on you, so you have to be ready for both really, really cold temperatures and really, really hot temperatures.
Hi, I'm just curious, with, for instance, the space station, using propulsion systems in space, since there's not a lot to push off of per se, how do they work?
That one is probably going to be pretty far outside my area of expertise. In general, you have an inertial mass from the vehicle itself that you push against. So there is a mass to overcome there, but how the systems exactly work is outside of my area of expertise.
And I think we can say though that it takes a lot less force to move you in space. Just you can see it on the International Space Station if you watch NASA TV. The astronauts can push off with just a finger and keep going for a long time. So it takes a lot less energy to move at all, and so that at least helps us getting around in space once we've gotten out of the Earth's atmosphere, which certainly does take a lot of thrust.
Yeah, once you don't have to overcome the gravitational vector, you can expend a lot less energy moving and translating.
Hopefully that helps answer your question.
Yeah, thanks.
I just gotta ask because I know that they wear suits, but with the systems itself on the station, how do you defend against solar flares that could also hurt the magnetics within the systems or the astronauts themselves?
All of the systems that go up on the space station are tested extensively, and there are specific precautions that are taken to protect against ionizing radiation events. With the crew themselves, there are certain instances where they locate in certain areas of the station. Occasionally, they locate in the water storage area because water ends up being a great shield for radiation. So we have large bags of water that we use to maintain a contingency reserve, and sometimes the crew will sleep in the proximity of those.
And we basically have space weathermen who let us know when there's going to be a lot of activity that we want to protect the astronauts from. So that helps us know when we need to maybe get them into an area, like Dan said, that has a little bit more protection than others.
As an environmental scientist, what is one of the most interesting side effects of being in space?
I would say that probably the most interesting aspect of maintaining environmental control systems in space is the lack of phase separation that you have when you're outside of or when you're in a microgravity environment. So for a water system, for example, which is one of the things that I'm the most familiar with, on the ground you don't get too concerned about air bubbles being trapped in the water supply because they always rise to the surface. Well, the reason the bubbles rise to the surface is because the gas is less dense than the liquid, and in a gravitational field it moves to the top. In the absence of that gravitational field, all the air bubbles stay entrained in the body of the liquid, and that can pose a lot of problems for fluid handling systems.
I was watching something and I read an article that there is over the last 60 or 50 years or so, there have been a lot of satellites put up that are just floating down Earth orbit. I think the number was like there's about 50,000 of them, and only about 1,000 are actually functioning. So they deem those, dead satellites space junk. Is there any efforts being used to clean that up, because they do pose a problem, especially for the International Space Station?
Again, I'm not aware of efforts. I know it's definitely something that is tracked very closely because folks always want to know if any of the orbital debris is going to pose a risk to the station.
Right. We have a team here on the ground that lets us know if there's any debris, which is what we call it, that's going to get anywhere near the space station, and if we need to, we move the space station around to avoid it. But as far as cleaning up, I know we're looking into different ideas, and hopefully are going to come up with an effort. Just because, like you said, it's getting to the point where there's so much of it in space, but a lot of it takes care of itself. It all eventually continues to lower in orbit, and then usually burns up in the Earth's atmosphere before it falls down. So, given enough time, it'll take care of itself. But there's so much of it, like you said, that we do want to try and find some other way to help out with the cleanup effort.
What new chemical discoveries have been made in space?
New chemical discoveries. There's a lot of interesting phenomenon that have been observed in space, a lot of them relating to the behavior of materials outside of or in the absence of gravity. There's been a lot of studies done on protein crystallization that they've seen some very novel crystallographic patterns that form in the absence of gravity. And there's probably some of the other things that have come about would really be material compatibility issues and exposure issues that things designed for space to tolerate the harsh environment of space then come back and find applications in extreme environments on the ground.
Hi. This is more of a political question than a science question. With our government $16 trillion in debt, the government funds NASA and spends billions of dollars a year on it. Why do you think that they should continue to do that?
That's a great question. Overall, when you look at the federal budget, NASA is a very small line item in the big picture, and the work that is done here is work that isn't done anywhere else and does have direct applications to the ground. It's fundamental science that benefits everybody. So myself, I work in the aerospace industry. I'm an advocate for the aerospace industry, and I think it's money well spent.
I definitely agree. You're right. It certainly is a lot of money to an individual like us, but like Dan said, in the big picture, you really don't spend a lot on NASA itself, less than 1% of the national budget, and I think we get a lot of bang for the buck out of it.
Hi. I was wondering, in the event of emergency on the space station, like running out of food or not being able to get back to Earth, does NASA have any plans in the case of emergency like that?
There are contingencies. There are plans in place to cover for just about every conceivable contingency that the crew would encounter. With regard to critical consumable items like food and water, there is a reserve that's maintained. It usually varies between 45 and 90 days, that if the crew were cut off or if there was a resupply slip, there are spares pre-positioned to sustain the crew during that launch delay. And there are evacuation plans that are in place that if a critical life support system were to be compromised, there are plans to get the crew safely back to the ground.
The woman previously talking to us said that occasionally, or not occasionally, but astronauts in training have to train for evacuation plans. If they actually had to evacuate the space station just for something, and they couldn't get to the right landing area, where would they land?
Well, so basically their lifeboats are the Soyuz vehicles that they came to Earth in, or came to the space station in. So they would just get back to those and get out of the space station, undock from the space station, and use those to land in where they actually land in Kazakhstan. So it's a big desert area. There's plenty of room for them to land, and they would have time once they got away from the space station to kind of plan their landing and make sure they ended up in the right place.
Specifically, how did you choose your career, and what steps did you have to take to become part of NASA?
It's an interesting question because I didn't really choose my career. It chose me to some extent. When I started off in college, I actually wanted to be a physical therapist and was taking a lot of biology courses, or trying to take a lot of biology courses that I got blocked out of, and my advisor at the time told me that I might as well take chemistry because that was going to be a requirement as well. I started taking my chemistry sequences through college and ended up taking an instrumental analysis and quantitative analysis class my freshman year, which really exposed me for the first time to using instrumentation to make chemical measurements and characterize different materials. And that just really intrigued me, and I stuck with it from there. Once I got my undergraduate degree, I went on to get a PhD at Iowa State up in Ames, and the professor that I worked for at Iowa State was working on a NASA research grant to develop water quality monitoring systems for the space station. So while I was in grad school, I started working on that project and was able to directly transition that to my job down here at JSC.
I think you hear that from a lot of the engineers and scientists who work at NASA, and I've also, talked with astronauts about that before as well. And they all say that what you should do is find something that you love doing, so that you will be inspired to be good at it, and then that will help you end up where you want to go, which hopefully could be NASA. And for myself, I work in the public affairs office at NASA, and started out as a newspaper reporter, and finding, even though I never intended to use it, the science classes that I took when I was in high school and college are really helpful for me now in kind of knowing what the scientists and engineers are talking about.
Would you be able to explain how the moisture system works in the system?
Which moisture system? Or do you mean the waste collection system on the space station that recycles water?
Yeah, that takes the moisture out of the air, so it gives the astronauts water.
Yeah, so what we have, there's two components to the water recovery. You do have condensing heat exchangers, so these are actually very similar to what you have in commercial and residential air conditioning units on the ground, where water condenses on the surface of these heat exchangers. It's then drawn into the water processor assembly. That atmospheric condensate that's collected is combined with distillate from the urine processor assembly to provide the feedstock for the water processor. The water processor itself uses a combination of processes to polish that combination of distillate and condensate back into potable water. It uses high temperature oxidation, ion exchange, there's some carbon sorbent beds, and then the final step before the water goes into the storage tank to supply the crew is addition of a biocide, which we use molecular iodine in the U.S. segment of the space station, and what that does is inhibits bacterial growth while the water is being stored.
On the space station, is it simpler on Earth for people in third world countries without water?
Is it similar to what people in third world countries could use? Is that what you asked?
The overall processes that we use on the space station to recover water, yes, are the same processes that you would use on the ground to take water or any contaminated water source and bring it back to a state that could be safe for human consumption. Of course, with NASA, the specific systems that we employ are purpose-built to operate in space, so they wouldn't necessarily be the best answer for a third world country. They're also built to sustain 6 crew at a time, not a village of hundreds of people. But the basic principles behind water recovery are exactly the same.
And we have engineers who work on the water recovery systems that we use in space who also volunteer their time to build systems that can work in third world countries and go out and help build them in the third world countries in some occasions and teach people how to use them.
Door and ventilation process with the water, when you only take out the H2O and take out everything else, or do you separate H2O and the nutrients needed for our body and dispose of the acids and chemicals from our systems?
With the condensing heat exchangers, you actually condense water along with any volatile organic compounds that could be present, along with some dissolved minerals that may be present in tiny microdroplets of water that exist. And there are metabolic components that come from the crew living and exercising in space that you condense in that moisture. When you go through the water recovery process, a lot of those contaminants are either broken down in the catalytic reactor, which is the oxidation unit. They're actually broken down to CO2 and bicarbonate and then scrubbed out using ion exchange beds. In the urine processor assembly, when we're distilling the urine and bringing over the distillate, there's actually a brine left that's a concentrated high ionic strength solution that's discarded in the progress vehicles and burned up.
Oh, so makes because they said it's purer than the water that we have today, and we use like similar nutrients to make sure our water's cleaner. So you use more concentrated ones, you're saying then?
No, the water the water that's produced on the space station is ultra pure water. It is much cleaner than the water that most of us have access to in the taps in our house. The what you need to remember is that on Earth, the water supply contains a lot of runoff from agriculture and industry that adds contaminants into the water that have to be removed with much more difficult processes. In the space station, we're fortunate in that the number of contaminants that we have to deal with are fairly limited because it's a closed loop environment. We're not using fertilizers. We don't have large industrial operations or agricultural operations. So we're really dealing with the metabolic load from the astronauts, and then some of the off-gassing components from the materials and the products that they use in space.
Another good reason to be an astronaut, right? You get cleaner water.
Absolutely. And you get to drink your own urine.
I think that's about all the questions we have time for at this time. Thank you so much, Dan, for joining us. We really appreciate you taking the time to answer some of these questions with us. And thanks so much to the students. We enjoyed talking with you. Hope we were helpful and were able to answer a lot of your questions. Have a great day. This is Mission Control Houston.